Chapter number 4, now topic number 4.7. So now we will discuss here molecular orbital theory. Clear? Now we will discuss here molecular orbital theory. See, in our chapter VBT is already discussed here. VBT, VSCPR. Now we will discuss here MOT. So first of all, see, MOT was developed by F. Hum and R.S. Mulligan. MOT was developed by F. Hum and R.S. Mulligan in 1932. And here important features of this theory are. Here we can say that important features of this theory are. तो देखिए important features आपको याद रखना है. The electrons in molecule are present in various molecular orbital as the electron of atoms are present in various atomic orbital. Here we can say that molecular orbital as well as atomic orbital. The electron in molecule are present in various molecular orbital as the electron of atoms are present in various atomic orbital. Clear? The atomic orbital, second feature, the atomic orbital of comparable energy. Here comparable energy and proper symmetry combine to form molecular orbital. The atomic orbital of comparable energy and proper symmetry combine to form, we can say that, molecular orbital. Now third one, while an electron in atomic orbital is influenced by one nucleus, while an electron in atomic orbital is influenced by one nucleus, in molecular orbital it is influenced by two or more nuclei. Here we can say that two or more nuclei depending upon the number of atom in the molecule. Depending upon the number of atom in the molecule. Thus an atomic orbital is monocentric while the molecular orbitals are polycentric. Here we can say that atomic orbitals are, we can say that, monocentric while molecular orbitals are, we can say that, polycentric. Clear? The number of molecular orbital formed is equal to the number of combining atomic orbital. The number of molecular orbital formed is equal to number of combining atomic orbitals. So when two atomic orbital combine, two molecular orbitals are formed. One is known as BMO and second is known as ABMO. So one is nothing but it is normally known as BMO and second one is nothing but it is normally known as ABMO. Clear? Now the BMO has lower energy and has greater stability than corresponding ABMO. The BMO has lower energy and hence greater stability than the corresponding ABMO. Correct? Now, just as the electron probability distribution around the nucleus in an atom is given by atomic orbital, the electron probability distribution around a group of nuclei in molecule is given by molecular orbital. Just as the electron probability distribution around a nucleus in an atom is given by atomic orbital, the electron probability distribution around a group of nuclei in molecule is given by molecular orbital. Clear? The molecular orbital, see, the molecular orbital like atomic orbitals are filled in accordance with the Aufbau principle, obeying the Pauli exclusion principle and Hund's rule. Clear हुआ? The molecular orbital like atomic orbitals are filled in accordance with the Aufbau principle, obeying the Pauli exclusion principle, and then after Hund's rule. So these are 7 important features of molecular orbital theory जो आपको अच्छी तरह से करना है. Clear? So these are, we can say that, 7 important features to which is related with respect to, here we can say that, molecular orbital. समझ में आया कि नहीं? तो साथ के साथ features आपको अच्छी तरह से याद रखना है. Clear? Now we will discuss here next one, the formation of molecular orbital according to LCAO. Formation of molecular orbital according to, we can say that, here is LCAO. So what is LCAO? So this is normally known as linear combination of atomic orbital. So this one is nothing but it is normally known as linear combination of atomic orbital. समझ में है कि नहीं? तो now we will discuss here means formation. Now we will discuss here means formation. The formation of molecular orbital with the help of LCAO. तो चलो डिस्कस करते हैं कि भाई ये LCAO वगैरह में क्या होता है. तो पहले ना यहाँ पे देखो फिगर दिया हुआ है. फिगर में आपको क्या करने का, सी यहाँ पे दिस इज psi A, this one is again we can say that psi A, and here we are taking increasing energy. तो यहाँ पे आपको क्या लेना है, तो here we can say that increasing energy. Clear? तो यहाँ पे देखो this is increasing energy. Now second one, this will be, here we can say that psi B is there. This one is nothing but it is now known as psi B. तो psi B में आपको क्या करने का, here this is condition, sigma is equal to psi A psi B. तो एक आप है एक डाउन है, इसको हम लोग क्या बोलेंगे, बॉन्डिंग. दिस इज बॉन्डिंग ऑर्बिटल lower energy than that of atomic orbitals. Here हुआ. फिर नेक्स्ट आता है here, नेक्स्ट वन ये आ जाएगा, यहाँ पे सिग्मा स्टार psi A psi B. तब इधर पे आपका क्या आएगा, तो दिस वन इज एंटी, दिस इज एंटी बॉन्डिंग ऑर्बिटल, एंटी बॉन्डिंग ऑर्बिटल हायर, दिस वन इज हायर एनर्जी देन दैट ऑफ एटॉमिक ऑर्बिटल्स. क्लियर हुआ? देखो इसको भी हम लोग क्या बोलते हैं, एटॉमिक ऑर्बिटल, और ये भी क्या है, एटॉमिक ऑर्बिटल्स आ गए. क्लियर? और ये है दिस इज मॉलिक्यूलर ऑर्बिटल. तो दिस वन इज नथिंग बट इट इज नॉन एज मॉलिक्यूलर ऑर्बिटल. तो चलो यहाँ पे आपको क्या करना है, फर्स्ट ऑफ ऑल सी, तो इधर अकॉर्डिंग टू वेव मैकेनिक्स, ये आपको स्ट्रक्चर ऑफ एटम मैंने बताया था, साइड. According to wave mechanics, the atomic orbital can be expressed by wave function psi, which represent the amplitude of the electron wave. These are obtained from solution of Schrodinger. Here we can say that wave equation. इसमें क्या करना है, however, see, since it cannot be solved from any system containing more than one electron, so molecular orbital which are one electron wave function for molecules are difficult to obtain directly from the solution of Schrodinger wave equation. To overcome this problem, an approximate method known as LCAO has been developed. Clear हुआ? Again I am repeating. However, since it cannot be solved for any system containing more than one electron, the molecular orbital which are one electron wave function for molecules are difficult to obtain directly from the solution of Schrodinger wave equation. To overcome this problem, an approximate method known as LCAO has been developed. So, so why we can say that LCAO is developed? Because see, in case of molecular orbital is applicable up to some extent, whenever number of electron will increases, then it is again we can say that not applicable. So now we will discuss here application of LCAO. So let us apply this method in homonuclear diatomic, it means hydrogen molecule. So consider hydrogen molecule consisting of two atoms A and then after B, and each hydrogen in ground state has one electron in 1s orbital. Clear हुआ? Here each hydrogen atom is related with respect to one electron in s orbital. The atomic orbital C, the atomic orbital of these atoms may be represented by wave function psi A and then after psi B. Clear? The atomic orbital of these atoms may be represented by the wave function psi A and psi B. So mathematically, the formation of molecular orbital may be described by LCAO that can take place by addition. Here we can say that addition and by subtraction of wave function of individual atomic orbital as shown below. तो क्या आएगा? Psi MO is equal to psi A plus minus psi B will be there. Clear हुआ? Now therefore the two molecular orbital sigma and sigma star are formed as the sigma is equal to psi A plus psi B and sigma star is equal to psi A minus psi B. The molecular orbital sigma formed by the addition of atomic orbital is called BMO, while the molecular orbital sigma star formed by subtraction of atomic orbital is known as ABMO. चलो same thing we can explain here. तो देखो ये कैसा है? हाइड्रोजन है तो Z is 1 तो 1s1 here psi A will be there. ऐसे फिर से ये है तो यहाँ पे क्या आ जाएगा? psi B will be there. This is psi A, psi B. In ground state addition will be there. तो psi A plus psi B इसी को बोलते हैं bonding molecular orbital, lower energy than that of atomic orbital. और यही जब ऊपर एक्साइटेड स्टेट में जाएगा तो psi star is equal to psi A minus psi B. तो this is normally known as anti-bonding orbital, have higher energy than that of the atomic orbital. So this is brief introduction of linear combination of atomic orbital, which is for we can say that hydrogen atom. Clear हुआ? तो this is complete information of formation of molecular orbital in case of hydrogen atom. ये फिगर अच्छी तरह से देख लेना. psi is wave function. Now in case of formation of LCAO, some remaining portion is, है ना? तो क्या बोलना है उसके अंदर? देखो, here we can say that qualitatively, this is qualitatively the formation of molecular orbital can be understood in terms of constructive or destructive interference of the electron waves of the combining atom. Clear? Qualitatively, the formation of molecular orbital can be understood in terms of constructive or destructive interference of the electron wave of the combining atom. Clear? In the formation of BMO, the two electron waves of the bonding atom reinforce each other due to the constructive interference, while in the formation of anti-bonding molecular orbital, the electron wave cancel each other due to destructive interference. Clear? Here, constructive interference will normally what will happen? Here we can say that intensity will increases, and destructive interference में what will happen? Here we can say that intensity will decreases. Clear? तो क्या बोला मैंने? Qualitatively, the formation of molecular orbital can be understood in terms of constructive or destructive interference of electron wave of the combining atom. In the formation of BMO, ground state, the two electron wave of bonding atom reinforce each other due to constructive interference, while in the formation of anti-bonding molecular orbital, electron wave cancel each other due to destructive interference. As a result, the electron density in bonding BMO is located between the nuclei of the bonded atom, because of which the repulsion between the nuclei is very less. In case of BMO, here we can say the repulsion will be very less, while in case of ABMO, most of the electron density is located away from the space between the nuclei, and here repulsion will be more. देख आपका BMO is situated in ground state, figure मैंने बताया था, and ABMO is again situated in excited state. Clear हुआ? In case of BMO, here chances of repulsion will be less. Therefore, this is perfect condition which is required for bond formation. While in case of ABMO, so this is an excited state, here repulsion will be more. Clear? Now there is a nodal plane. What is the meaning of nodal plane? The plane in which to find out electron possibility is 0. So there is a nodal plane between the nuclei and hence repulsion between the nuclei is high. Here we can say that repulsion is high. Electron placed in bonding molecular orbital tend to hold the nuclei together and stabilizes a molecule. है ना? यहाँ पे क्या होगा? Therefore a bonding molecular orbital always possess lower energy than either of the atomic orbital that have combined to form it. Clear? So there is a nodal plane between the nuclei and hence the repulsion between the nuclei is high. The electron placed in bonding molecular orbital मतलब BMO tend to hold the nuclei together. BMO में क्या होता है? Bonding होता है and stabilize a molecule. वो stable हो जाता है. Therefore a bonding molecular orbital always possess lower energy than either of the atomic orbital that have combined to form it. Clear हुआ कि नहीं? Now in contrast the electron placed in ABMO है ना, देख bonding और anti bonding का comparison है. In contrast the electron placed in ABMO destabilize the molecule. So why destabilization will be occur? So because here we can say that repulsion will take place. In case of ABMO, here repulsion will take place. So this is because the mutual repulsion of electron in this orbital is more than the attraction between the electron and nuclei, which causes a net increase in energy. In case of ABMO, due to repulsion, here what will happen? The energy will increases. But in case of BMO, repulsion is not there. Here we can say that energy will decreases. So this is remaining portion of, we can say that LCAO. Again I am repeating, qualitative here means constructive and destructive interference will take place. And then after in case of constructive interference, chances of BMO is there. While in case of destructive interference, chances of ABMO is there. Clear? In case of BMO, chances of repulsion will be less. So bond formation will be more. While in case of ABMO, here we can say chances of repulsion will be more. Here bond formation will be less. Now, it may be noted that energy of ABMO is raised above the energy of parent atomic orbital that have combined, and energy of bonding orbital has been lowered than the parent orbital. The total energy of 2MO, however, remains the same as that of two original atomic orbital. Clear हुआ कि नहीं? It may be noted that energy of ABMO is raised above the energy of parent atomic orbital that have combined, and the energy of bonding orbital has been lower than the parent orbital. The total energy of two molecular orbital, however, remain the same as that of two original atomic orbital. समझ में आया? So this is complete information of LCAO. So this is complete information of LCAO. Now our next topic is 4.7.2. So this is condition for the combination of atomic orbital. So whenever we are forming atomic orbital, then some conditions are required. So these conditions are is again is as follows. देखो, the linear combination of atomic orbital. ये देखो, linear combination of atomic orbital to form molecular orbital take place only if the following conditions are satisfied. Here three conditions are: the combining atomic orbital must have the same or nearly the same energy. Here we can say that must have the same, or we can say that nearly the same energy. जैसे यहाँ पे देख 1s will combine with 1s only. 1s will never combine with 2s. Why? Because 1s is member of K cell, while 2s is member of, we can say that, L cell. It means in case of during bond formation, whatever orbital will combine with each other, its atomic, its, we can say that, energy should be same. Now second one, the combining atomic orbital must have same symmetry. Here we can say that symmetry should be same about the molecular axis. By convention, here by convention z axis is taken as the molecular axis. It is important to note that atomic orbital have same or nearly the same energy will not combine if do not have same symmetry. Clear हुआ? Energy चल same है, but यदि symmetry same नहीं है, here we can say that combination is not possible. याद रखना, here suppose if energy is same, but we can say that if symmetry is not same, here we can say that combination is not possible. For example, 2pz orbital of 2pz orbital of atom, one atom can combine with 2pz orbital of other atom, but not with 2px and 2py orbital because of their different symmetry. Clear? मतलब pz होगा तो bond formation is possible, but pz will not form bond with the help of px. Clear हुआ? Now third requirement is the combining atomic orbital must overlap the maximum extent. Here we can say that orbital, here overlapping should be maximum. Here we can say that overlapping should be maximum. So greater the extent of overlap, the greater will be the electron density between the nuclei of molecular orbital. Clear हुआ? Again I am repeating. So greater the extent of overlap, है ना? If greater the extent of overlap, the greater will be the electron density between nuclei of molecular orbital. In this way, during combination of atomic orbital, three important conditions are: for first of all, energy should be same. Second one, symmetry should be same. Energy should be same, symmetry should be same, and overlapping should be maximum. ये देख दो नंबर में आएगा, है ना? Conditions for we can say the combination of atomic orbital. Here whatever atomic orbital will form bond, here we can say that energy should be same, symmetry should be same, and here what will happen? Overlapping should be maximum. It means if these three conditions will be satisfied by any, we can say that here means orbital, then here we can say that molecule will form very easily. ये दो नंबर में आता है, conditions for combination of atomic orbital. अब चलो पता कैसे चलेगा कि एनर्जी सेम है? तो whatever orbitals are, है ना, it should be related with same shell. जो देखो ये 1s will combine with 1s, but 1s will never combine with 2s. Why? Because 1 है मतलब k cell है और 2 है मतलब l cell will be there. क्लियर हुआ कि नहीं? फिर ऐसे देखो आपका at same symmetry, तो सिमेट्री के लिए फॉर कन्वेंशन पर्पस वी आर टेकिंग हियर मींस z एक्सिस, है ना? और उसके बाद ओवरलैपिंग, तो मैंने वीबीटी में बताया था हाइड्रोजन वाला कि कौन सी कंडीशन को हम लोग ओवरलैपिंग बोलते हैं. इफ ओवरलैपिंग विल बी अगेन वी कैन से दैट मैक्सिमम. तो ओवरलैपिंग का मैं कैसे बताऊं? सी फॉर एग्जांपल जैसे हाइड्रोजन है ना? इन केस ऑफ हाइड्रोजन जो भी मैंने आपको समझाया, इन केस ऑफ हाइड्रोजन नॉर्मली व्हाट विल हैपन? सी दिस इज हाइड्रोजन, this one is hydrogen, Z is 1, 1s1 ये है, ऐसे ये HA, ऐसे ही HB, Z is 1, 1s1. तब क्या करने का? ये देखो इधर पे दो हाइड्रोजन एटॉमिक ऑर्बिटल है, यहाँ पे पहले डिस्टेंस इज मोर, फिर एक दूसरे को क्या करेगा? टच करता है. क्लियर? फिर ओवरलैपिंग विल स्टार्ट. तो सी, तब देखो ये फिगर A है, ये फिगर B है एंड ये फिगर C है. हियर C, इसको हम लोग बोलते हैं सिग्मा बॉन्ड एंड हियर ओवरलैपिंग इज मैक्सिमम, देयरफॉर बॉन्ड स्ट्रेंथ ऑफ C इज मोर एज कंपेयर टू B. क्लियर? इसी को हम लोग क्या बोलते हैं? ओवरलैपिंग शुड बी मैक्सिमम. करेक्ट और नॉट? चलो